Hello makers, in this tutorial we will send sensor data from NodeMCU ESP8266 Arduino board to ThinkSpeak IoT Server Dashboard. First you need to go to google.com and search for ThinkSpeak and click on the first link to create your ThinkSpeak account, which we will be using to collect, store, and display sensors data from NodeMCU ESP8266 Wi-Fi Arduino board. If you have already created a ThinkSpeak account, you can simply type your email and password to log into your account. But if you do not have ThinkSpeak account before, you need to click Create One and submit your email, location, and your name. Then simply press Continue. To use organizational MATLAB, enter your organization or university email, or click on Use this email and press Continue. Now, to finalize ThinkSpeak account creation process, you need to go to your inbox and click on the link sent to you from ThinkSpeak and press Continue to verify your account. Finally, you need to create a strong password to your account. Now, you have successfully created your ThinkSpeak IoT account. We will create a new IoT-based weather station project. Click on New Channel, give the project name, describe the project, and list down the fields which you plan to have. In our case, our project name will be NodeMCU ThinkSpeak Project. You can also describe the project on the description part for clarity purpose. Now, we need to write the field's name. For our project we will have 3 fields. Those are temperature, humidity, and light intensity. But instead of typing myself for the sake of avoiding error, I prefer to copy those field names from the string row part of the Arduino code to avoid any typo error. In case if you wish to add additional field, you can simply add the field both on the Arduino code, including in the string URL part using the same format, and you also need to add it on the ThinkSpeak field list. Once you make sure that the ThinkSpeak channel is as you wish to publish, you can simply press Save Channel. As you can see, we got 3 different charts for our 3 fields. Each chart has the project name, field name on Y-axis, and date on X-axis. But there is no any graph because we do not send any sensor data to ThinkSpeak yet. We can customize the chart's property by clicking the pen icon on the top right part of each chart. You can change the title, X-axis, Y-axis, color of the graph which you will not be able to see it. Even if I change the color of the graph and save the change, I cannot see the change because since we do not have any data to display, even if we change the color of the graph, we have no graph. But if we change the background color and save the change, we can see the effect immediately. You can also play around the other properties to customize as per your preference. We can keep our channel private, share it with specific group through email, or simply, we can share it with everyone. In case if you made any error when creating the channel, or if you want to add a new field, you can edit it from the channel setting part. You can upload or import existing data into your ThinkSpeak channel in CSV format. You can also download or export data from ThinkSpeak in CSV format. We also have write and read API keys. Write API key. We use this key to write data to a channel. If you feel your key has been compromised, click Generate New Write API Key. Read API keys. We use this key to allow other people to view our private channel feeds and charts. Click Generate New Read API Key to generate an additional read key for the channel. Now, we have finalized the ThinkSpeak part of our project. Let's go to the Arduino code. First, we need to include necessary libraries for our project. Then you have to submit your Wi-Fi name and Wi-Fi password and Wi-Fi SSID and password respectively. We must copy and paste our ThinkSpeak channel write API on string API to send data from NodeMCU to ThinkSpeak server. Now, we need to initialize temperature, humidity, and light as integer with 0 value. The void setup function executes first and only once upon device startup. serving as the initialization block for your NodeMCU program. This specific code first sets up serial communication at 115,000 to 100 baud for debugging, and then configures the NodeMCU to connect to a Wi-Fi network in station mode. Finally, it waits until the Wi-Fi connection is successfully established, printing the device's assigned IP address to the serial monitor. The void loop function is the heart of your Arduino code, running continuously after the setup is complete. The first step inside this loop is reading the sensor data. In our current example, we're using the random function to simulate sensor readings for temperature, humidity, and light. This saves time for the tutorial, but to work with a real sensor, you would simply replace these random calls with the actual sensor reading logic. It's that easy. We then print these current values to the serial monitor for debugging. Next, we have a critical if statement that checks if the NodeMCU is still well connected to the Wi-Fi network. If the connection is active, we proceed to send the data. We initialize an HTTP client object and construct the full API URL to send our data to ThinkSpeak. Notice how we append each piece of data, such as temperature, using the format, and field 1 equals to plus string of the value. If you need to send more data, you can simply add extra fields in the same format, like in field n equals to followed by the string of your new data field. The http.get command sends the request. If the HTTP code is positive and equals HTTP code OK, we know the data update was successful, and the serial monitor confirms the entry ID. If the Wi-Fi is not connected, the else block triggers, printing a warning and attempting to reconnect to the network. Finally, the delay 5000 command pauses the program for 5 seconds before the entire void loop function executes again. This ensures we don't spam the cloud server with too many requests, maintaining a reliable, repeating cycle of read, connect, and transmit. Now, it is time to choose the board and COM port to upload the code. First, let us choose the Arduino board. Go to Tools, Board Manager, ESP8266, and choose NodeMCU 1.0. Press the right icon to verify that our Arduino code is error-free. Until it verifies, please take your time to subscribe and like the video. As you can see, our code is error-free, so let's choose our COM port to upload our code. But before choosing COM port, we must connect our board with our computer. After we choose the correct COM port, we need to press the right arrow button to upload the code to our NodeMCU. All the chart did not have any data displayed so far, but now, we expect to see a real-time sensor data on the y-axis of the 3 charts, which will be generated randomly in the given ranges with time on x-axis. Voila! We are able to see our very first sensor data on the 3 charts. We will get additional temperature, humidity, and light data every 5 seconds, as long as our NodeMCU board has power and internet. As we discussed before, you can customize the graph as per your preference. The data is also displayed in the serial monitor. If we need the data, we can simply export the collected data in form of CSV Excel file. Now, the exported CSV Excel file can be utilized for data analysis, machine learning, data recording, or other purpose, based on our project final goal. Thank you for your time.